What if I told you that one of the most ridiculous-looking armored cars in history turned out to be a lethally brilliant weapon? Imagine a machine with 8 wheels, 2 steering wheels, and steel teeth instead of tires, that its crew called a mechanical nightmare. Its design broke every conceivable rule, and repairing its engine was like performing surgery under fire. French generals first laughed at this project, but just a few years later, these same machines became their only salvation in the bloody hell of colonial wars. This is the story of the Panhard EBR, Engin Blindé de Reconnaissance, Armored Reconnaissance Vehicle, an armored car that could drive backwards faster than some tanks could go forwards. A machine whose secret prototype vanished without a trace under mysterious circumstances, and whose main feature could kill its own crew at any moment. We'll tell you how engineering madness defeated common sense, why soldiers hated and loved this vehicle at the same time, and how it ended its journey carrying the coffin of Charles de Gaulle himself. This was an adventure that shouldn't have succeeded, but it did. Watch until the end. The truth about the steel chameleon with 2 faces will shock you. Algeria, 1958. Scorching air shimmers over a dusty road squeezed between cliffs. A column of French armored vehicles slowly moves along the bottom of a stone trap when the silence is shattered by a burst of gunfire. From above, from the slopes, they are hit with everything available. An ambush, a classic guerrilla tactic, executed flawlessly this time. The path forward is blocked by a pile of stones. Any other vehicle would be trapped, no room to turn around, and exposing its thin sides to deadly enfilading fire meant certain death. But the lead armored car doesn't try to turn. Instead, it lurches forward, picks up insane speed, and rushes backwards. Its turret continues to rotate and fire at the attackers' positions. 13 tons of steel and armor fly in reverse at 80 kilometers per hour, controlled by a second driver sitting in the rear, seeing the road as clearly as if he were moving forward. In a matter of minutes, the vehicle escapes the kill zone, barely damaged. To the guerrillas, it seemed like witchcraft. Before them was the Panhard EBR, an armored reconnaissance vehicle whose design challenged everything known about warfare. But how and why did French engineers create such a marvel? The answer lies in the very nature of mid-20th century France, the last great colonial empire whose holdings stretched from African deserts to Asian jungles. Controlling these vast spaces was incredibly difficult. Heavy tanks were useless here. They bogged down in sand, overheated, and their insatiable appetite for fuel broke any supply line. A fundamentally different solution was needed, a vehicle capable of rapid, long-range dashes on and off-road, carrying a powerful enough gun to suppress resistance, yet simple to maintain. This was the challenge Panhard, already successful with the light P-178 armored car, decided to answer. But chief designer Louis Delagarde thought on a much grander scale. Even before the war, a revolutionary vehicle project was taking shape in his mind. Its prototype, the Panhard 201, saw the light of day in 1940. This was not just an armored car, but an engineering fantasy brought to life. 8 wheels, with the 2 middle pairs being solid metal with track-like grousers. 2 full-fledged control posts at the front and rear allowed it to drive in any direction with equal efficiency, and its absolutely symmetrical, pike-nosed hull was disorienting at first glance.
The French War Ministry was so impressed that on May 1, 1940, it placed an order for 600 such vehicles. But this bright future shattered just 6 weeks later. German divisions broke through the front, and France fell. The only built prototype was hastily evacuated to Morocco, far from the advancing enemy, and there its trail disappeared. What happened to it remains one of the war's secrets. Perhaps it was destroyed to prevent capture. Perhaps it simply vanished in the chaos of retreat, abandoned and forgotten in the sands of North Africa. It seemed Delagarde's mad and brilliant idea was forever buried under the rubble of defeat. However, the boldest ideas have a strange property. They don't die. They wait for their moment.
But Louis Delagarde did not give up. He spent the years of German occupation not in idleness. Under conditions of utmost secrecy, risking his freedom and life, the designer continued to refine his blueprints. He analyzed the prototype's flaws and made adjustments. The key improvement was the decision to make the front and rear parts of the hull not just similar, but absolutely identical. This was a genius move from a logistics and economy standpoint. Now the same stampings, parts, and assemblies could be used for both ends, which in the future would drastically reduce cost and speed up mass production. The idea, born before the war, matured underground, awaiting its moment. That moment came in 1945, but the France to be rebuilt was a sorry sight. Industry lay in ruins, the economy was exhausted, and the army needed complete re-equipment. It seemed like no time for ambitious and expensive projects. Yet imperial problems hadn't gone away, they had only worsened. On the other side of the world, war was raging in Indochina, and in North Africa, a simmering discontent threatened to erupt into open rebellion. To hold the crumbling empire together, Paris desperately needed a new tool, fast, intimidating, and perfectly suited for punitive raids and police operations across vast colonial expanses. That is why, in September 1949, when the country had not yet recovered from its wounds, work on the miracle armored car officially resumed. The project was named Panhard EBR, Engin Blindé de Reconnaissance, and on July 14, 1950, Bastille Day, it made its triumphant and slightly surreal debut on the Champs-Élysées. Amid the rumble of tracks and roar of engines, low, swift silhouettes with the characteristic pike noses glided smoothly down Paris's main avenue. The public applauded, seeing in them a symbol of resurgent French military might. No one could have guessed then that these elegant machines were destined not for parade duty, but for long decades of dirty, brutal colonial wars, where their unique abilities would be tested to the limit. But before the EBR could go to war, engineers had to solve a puzzle comparable to assembling a mechanical watch inside a matchbox. The two-control post, symmetrical end design left no conventional space for the heart of any machine, the engine. The drivers sat in the nose and stern. Only one seemingly unsuitable space remained, the very center of the hull, right under the turret. No mass-produced car or tank engine would simply fit there. The creators of the EBR faced a seemingly insoluble task. They didn't need to find an engine, they had to reinvent it from scratch. The solution Panhard engineers arrived at was as radical as it was brilliant. They gave up looking for a suitable serial engine. It simply didn't exist. Instead, they started from a blank slate to create a power unit from the ground up, subordinating it to a single goal, fitting into the unbelievably tight space under the turret. The result of their work was a true masterpiece of compactness, a self-developed 12-cylinder horizontally opposed gasoline engine. The secret to its incredibly low height lay in its very architecture. The cylinders were not vertical,
but laid flat in 2 rows of 6 each, opposite each other like boxers in a ring. Their pistons moved in the horizontal plane towards each other, allowing the entire power plant to be compressed into a flat pancake. To reduce production costs and use proven technology, the designers showed ingenuity. They based the cylinder piston group components on parts from the small civilian Panhard Dynacar. From a modest economy car grew cylinders for the heart of a combat vehicle. The result was a unique engine that in its miniature size delivered a very respectable 200 horsepower, giving the 13.5-ton armored car excellent power-to-weight ratio and potential for high speeds. But hiding the machine's heart was just the beginning of the story. Now they had to make that power work, and here engineers faced perhaps the most complex puzzle in the entire project. The task sounded fantastic. They had to transmit torque to all 8 wheels while giving the vehicle the ability to move forward and backward with absolutely identical characteristics: same speed, same handling, same efficiency. The EBR essentially had no reverse gear in the classical sense. It had a second front-facing control post, and it was supposed to just drive in the opposite direction. Standard transmission schemes didn't suit this. The answer was a sophisticated, incredibly complex, yet brilliant choice: a double-side transmission. In it, power from the engine was distributed not by axles, front, middle, rear, but by the sides of the vehicle. The right and left sides became independent of each other. The central element of this system was not 1, but 2 gearboxes, combined into a single unit in an off-axis scheme. This double gearbox served as the Swiss Army knife of transmissions. It was a gearbox, a transfer case, a lockable inter-side differential, and a reversing mechanism for changing direction of travel. The main tactical advantage of this design was phenomenal cross-country mobility. It completely eliminated one side from spinning out. If the wheels on the left side, for example, hit ice or mud and started to slip, the right side kept pulling the vehicle forward without losing a gram of traction. This was a lifesaver off-road. But, as always, perfection came at a price. The cost was mind-boggling: complexity. In the EBR's transmission, the torque changed direction several times at right angles, passing through a labyrinth of gears, angular drives, and bevel gears. Each such connection sapped some energy, leading to significant power losses and a rather low overall efficiency for the entire system. This was a machine where engineering elegance and tactical rationale triumphed over simplicity and economy. And while this ingenious mechanical heart beat in the center of the hall, the EBR's external appearance was preparing its own completely non-obvious and very unpleasant surprises for anyone who met it on the battlefield.
If the EBR's complex transmission was a hidden engineering marvel, its external appearance was a pure, almost brazen tactical declaration. The complete, absurdly symmetrical hull was not a designer's whim, but a carefully calculated survival tool embodied in steel. At a glance, it was impossible to tell its front from its rear. Both pointed, swift ends were absolutely identical, and in each of these wedge-shaped nose parts sat not a hatch or a spare station, but a full-fledged, fully equipped driver's seat with its own rectangular entry hatch, a set of levers, pedals, and observation instruments. This feature radically changed its tactical application. A conventional armored car, ambushed in a narrow defile, found itself in a death trap. Turning around took time and space it didn't have. The EBR simply changed direction without changing position. As in that Algerian episode, the rear driver instantly took control, and the 13-ton behemoth rushed backwards at full road speed, while the turret kept rotating and returning fire. The enemy, expecting confusion and a vulnerable maneuver, saw its prey literally slip out of the trap without presenting a single weak side.
For a reconnaissance vehicle whose job is to look into the lion's mouth, this ability for an instant bounce back was priceless. The characteristic pike nose, formed by 3 armored plates converging at different angles, wasn't just a recognizable feature. At its base hid a small but critically important element, a massive cast piece of 40 millimeters, which designers jokingly called the jaw. At first glance, its dimensions were too modest to provide serious protection from shells. It only shielded one driver's legs. But its true mission was different, structural. This jaw acted as the most powerful frame member, the central rigidity node. It tied all the sloped armored plates of the front and rear into a single monolithic frame, preventing hull deformation on bumps and overcoming obstacles. Without this seemingly minor detail, the EBR's long and relatively narrow hull might not have withstood the harsh trials of off-road travel. Inside this well-thought-out steel cocoon was a crew of 4, whose work followed a clear logic. The 2 drivers were the machine's heartbeat, working in shifts in their isolated cabins at opposite ends of the hull. While one drove the armored car forward, controlling the road through his observation devices, the other could watch the rear hemisphere, rest, or be ready for an immediate course change. The commander and gunner, or loader depending on the turret model, occupied their places in the fighting compartment. This system made the EBR ideal for long, grueling raids, where the attention of a tired driver could cost the whole team their lives. However, all these innovations, the symmetrical hull, 2 control posts, the engine hidden in the center, were, in essence, magnificent preparatory work. They set the stage for the main character, the brightest and most insane invention of the French engineers in this project. The true pièce de résistance of the Panhard EBR, the thing that left military specialists around the world throwing up their hands in admiration and bewilderment, was not at eye level, but under the vehicle's belly. All the genius, complexity, and audacity of the concept converged in one assembly, its running gear, which had and still has no analog in the history of armored vehicles.
It was here, in the running gear, that the Panhard EBR philosophy reached its zenith. Looking at it, it was hard to shake the feeling that you were looking at a blueprint from a sci-fi novel. The 8 wheels were divided into 2 fundamentally different types. The 4 outer ones, the front and rear pairs, looked familiar. They were standard wheels with pneumatic tires, like on a truck. But the 2 middle pairs were mind-blowing. Instead of rubber, they sported solid metal discs made of aluminum alloy, around the circumference of which ran powerful gear-like grousers. These steel stars seemed like the offspring of engineering insanity, but behind their futuristic appearance lay precise calculation. They were made for one thing: to dig into loose sand, sticky mud, and rocky scree, providing traction where ordinary tires would be helpless. But the real magic was that these middle axles were retractable. When driving on hard roads, asphalt, or compacted ground, the driver, using a hydro-pneumatic actuator, raised these steel wheels up. The vehicle, resting only on 4 pneumatic wheels, turned into a 4x4 and could race down the highway without creating unbearable noise or tearing up the road surface with its teeth. But as soon as it went off-road, a lever lowered the middle axles, and the EBR gently settled on all 8 points of support. Now, its ground pressure dropped to an incredibly low 0.7 kilograms per centimeter squared, lower than many tracked vehicles. The 13-ton armored car gained the ability to travel over swampy sand as if on asphalt. This lifting mechanism also served as a suspension's elastic element, smoothing out shocks on uneven terrain. The outer wheels, meanwhile, had independent suspension with concentric springs. And, importantly, all 4 outer wheels were steerable.
This gave the long vehicle phenomenal maneuverability. With a turning radius of just 6 meters, it could practically turn on a dime, a lifesaver in the narrow streets of Arab Medinas or on mountain switchbacks. The result of this titanic work on the chassis was performance that in the 1950s seemed from the future. Top speed on the highway, 105 kilometers per hour, making the EBR one of the world's fastest armored objects. Range, up to 630 kilometers, providing incredible autonomy for deep raids. It could cross trenches up to 2 meters wide on the move, and its stability and smooth ride at high speed became legendary. However, every coin has a flip side. The enormously complex running gear and transmission required highly skilled mechanics, but the crew's main curse was repairing that very compact engine. To get to it, you first had to dismantle the multi-ton turret along with the gun, an operation requiring a crane, time, and the absence of the enemy nearby. The irony was that this very turret, so hard to remove, was another revolutionary element of the vehicle, defining its combat power. Its design also broke stereotypes, but at the same time harbored a dangerous, almost fatal flaw. This multi-ton turret, so hard to remove for repairs, was in itself a technical sensation. The EBR was fitted with a so-called oscillating turret, a concept radically different from the classic one. It consisted of 2 parts. The lower part, fixed relative to the hull, rotated on a turret ring, providing horizontal aiming. The upper part, in which the gun was rigidly fixed, oscillated on trunnions relative to the lower one, moving up and down for vertical aiming. This allowed for simpler and more compact aiming mechanisms. The French, true to their pragmatism, did not develop a turret from scratch, but used ready-made, proven solutions. Some vehicles received the famous FL-10 turret from the AMX-13 light tank. Its main trick was a drum autoloader, 2 rotating magazines of 6 shells each, allowing for a phenomenal rate of fire for the time, up to 12 rounds per minute. The crew was reduced to 3, as there was no need for a loader. However, this advantage came at a terrible price. When both drums were empty, reloading them from inside the vehicle was impossible. A crew member, most often the commander, had to climb out through a hatch and, under possible fire, manually, shell by shell, stuff the magazines through a special hatch in the turret's rear. This procedure in the heat of battle turned the commander into a perfect target. Therefore, another, simpler turret without this drawback was more common in the troops, the FL-11. It had no autoloader. Shells were loaded manually by a loader, making the crew 4 again and reducing the rate of fire, but sparing the deadly battlefield reloading. Over time, the armament was strengthened. In 1963, an upgraded version, the EBR-90, appeared, armed with a new 90mm gun firing heat shells capable of penetrating up to 320 millimeters of armor. Now the armored car could even threaten heavy tanks. However, the very concept did not involve meeting them in open combat. Moderate armor, front hull and turret 40 millimeters, sides 20 millimeters, was a conscious compromise for speed and mobility. These 40 millimeters, sloped at rational angles, could protect from bullets and shrapnel, but no more. The EBR was created not for duels with steel giants on the battlefield, but for a different kind of war, colonial, mobile, and merciless. And it was in such conflicts, where speed and surprise mattered more than armor thickness, that the Panhard would to undergo its baptism of fire and earn its legendary reputation.
The proving ground for the Panhard EBR turned out to be harsh and bloody. The Algerian War of Independence, raging from 1954 to 1962. Here, in the endless deserts and on mountain trails, two opposing doctrines clashed. FLN guerrillas relied on surprise, ambushes, and swift retreat, and it was against this tactic that the EBR revealed its full potential. Its speed allowed it to be the first to arrive at the scene of an attack or intercept retreating groups. A range of hundreds of kilometers enabled long, punitive raids deep into rebel-controlled territory. Off-road capability, provided by the steel gear wheels, made it immune to the most difficult terrain. And the 75mm or 90mm gun, with its high muzzle velocity, allowed it to effectively destroy cover and fire from long distances. In the Algerian heat and dust, the machine's complex design showed surprising resilience, proving that engineering madness could be quite practical. Success in Algeria opened the door to exports. Countries facing similar problems eagerly purchased it. Panhard served in Morocco and Tunisia, in distant Indonesia, and in Portugal, which used it in its grueling colonial wars in Angola, Mozambique, and Guinea-Bissau. The vehicles of the 1950s remained in demand even in the 1970s, participating in the Western Sahara conflict. They became a reliable tool of small wars for those trying to hold on to slipping control over vast spaces. In the French army, the EBR's career gradually came to an end by the mid-1980s. Morally and physically obsolete, they gave way to more modern vehicles, finally transitioning into the role of training aids. But the history of this unusual armored car received a finale with deep symbolic meaning. In November 1970, Charles de Gaulle, the man who embodied French resistance, liberation, and rebirth, passed away. According to his will, there were no lavish state funerals. The coffin with the general's body was to be taken from the church in his native village of Colombey-les-Églises to the cemetery, not on a luxury hearse, but on a simple army tractor. But at the family's request, and with the authorities' permission, at the last moment it was replaced. The father of the nation made his final journey on a platform mounted on a Panhard EBR chassis, with its turret removed. The machine created to hold on to a dying empire, a machine of war and suppression, escorted the man who was a symbol of freedom and sovereignty. In this gesture lay a strange and powerful paradox, putting a period on an entire era. Thus ended the story of one of the boldest experiments in the history of armored vehicles. The Panhard EBR was not a perfect machine. It was complex, expensive, vulnerable in frontal combat, and required skilled maintenance. But it became the perfect answer to a specific, historical challenge. It was a brilliantly executed, specialized job, where engineering audacity, tactical ingenuity, and political necessity intertwined into a unique mechanism. It proved that sometimes the craziest solution turns out to be the only right one, and a machine created for one war can forever remain in memory as a symbol of an entire time, a time of desperation, inventiveness, and fading imperial might.